Our next talk is asking clarification questions in knowledge-based question answering, presented by Jingjing Xu from Peking University.
Good afternoon, everyone. I'm Jingjing Xu from Peking University. Today, I'm glad here to present my written work about asking clarification questions in knowledge-based question answering. In real-world communication, ambiguity is a very common phenomenon because many questions are not clear enough. Like an example shown in this slide, what are the languages used to create the source code of Midori? There are two entities with the same name Midori, but using different programming languages. So it is for this this question confuses the system. So for these ambitious or confusing questions, it is hard to directly give a satisfactory answer unless a system can ask a clarification question to confirm the participant's intention. Therefore, in this work, we try to explore how to use clarification to improve current knowledge-based question answering systems. Considering that there lacks existing training corpus for clarification, so we build an open domain clarification dataset for KBQA task. Unlike previous clarification related datasets, our dataset unlike previous datasets with limited size or in specific domain, our dataset covers various domains and supports 3 tasks. The comparison of our dataset and related datasets is shown in this slide. And based on the clarification reasoning pipeline, we formulate 3 tasks in our dataset, including clarification identification, clarification question generation, and clarification-based question answering. Since asking too much clarification questions significantly decreases the conversation quality, so we designed the task of identifying whether clarification is needed. If no clarification is needed, the system can directly respond. Otherwise, the system needs to generate a clarification question to request more information from the participant. And then the external user feedback is used to predict the answer. So here is the brief introduction about our 3 tasks. Our dataset contains 2 kinds of ambiguity for singleton case, for singleton and multi-turn questions. In the singleton case, an entity name refers to multiple possible entities in a knowledge base, and the current utterance cannot. And the current utterance lacks enough identifying information to distinguish between them. And in multi-turn case, the ambiguity mainly comes from omission of the target name, where a pronoun refers to multi-possible entities in the previous conversation turns. And here are 2 our annotation examples. We use multi-choice as our basic type of clarification. There are 3 possible clarification types in total, including zero choice type, single choice type, and multi-choice type. Zero choice type means that I don't know. Can you give me more details? The single choice type means that looks like which one do you mean? Do you mean A? The multi-choice type looks like which one do you mean, A or B? The zero choice type means that the system does not understand the system, and it expects more details from the participant. Although it is simple, it needs more participants' efforts because it pushes the participant to figure out what confuse the system. In comparison, single choice, the advantage of a single choice type lies in the control of conversation direction. However, if the system cannot give satisfactory or user-affected candidates, the conversation would be longer. So as for the multi-choice type, the advantage is that it can use less conversation turns to ask for more valuable information. So that's why we choose multi-choice as our basic type of clarification. And the construction process contains 3 steps. The first step is subgraph extraction. We first define some rules to extract ambitious graph from a knowledge base. The extract subgraphs are used to provide a reference for human annotators to write diverse, ambitious questions. And the second step is ambitious question annotation. In this step, the input is a table listing all graph information, and based on this table, annotators are required to write diverse, ambitious questions. The third step is clarification annotation, clarification question annotation. Based on the input graph information and the annotated ambitious question, the human annotators are required to summarize the key distinguishing information from entity information and write a clarification question. In this step, also additional user feedback are also necessary. So due to considering the strong patterns in responses, we use a template. We use a template-based method to generate the feedback. We first design several templates and randomly select a candidate entity and fill the selected entity information into the template to add the user response. And here is an example for singleton case. In singleton case, we focus on shared name and ambiguity, where 2 entities have the same name and there lacks enough identity distinguish information. So to construct such cases, we extract 2 entities sharing the same name and the same predicate. Based on these ambitious subgraphs, the annotators are required to write ambitious questions and clarification questions. And here is an example for multi-turn case. In multi-turn case, ambiguity comes from the mention of the target entity name from the previous conversation turn. We first extract 2 connected entities. If they are also share another predicate, we extract all related information as an ambitious subgraph, as shown in this slide. By asking the shared predicate, we can get an ambitious question. Here is the instruction. Here are the details of our clarification identification task. Clarification identification can be regarded as a classification problem. It takes the input is the context and candidate entity information. The output is a binary label where label 1 indicates that the input question is ambitious, and the label 0 indicates the the input question is clear enough. And also for classification tasks, negative examples are also necessary. So in our work, the negative examples are annotated in the same way as the positive examples do, but without the clarification-related steps. In their subgraphs, one of the entity is related. One of the entity has a unique predicate. If we ask for this unique predicate, we can get an ambitious question, that is clear question. Oh, sorry. We also implement 2 kinds of models, including structure models and abstract models as our baseline. And structure models directly concatenate graph information and entity information together into a long sequence. And we adopt several widely used text sequence classification models as baselines, including CNN and the transformer. The structured models use separate structures to encode the graph information and content information, and then adopt an additional structure to fill them together. Specifically, we use 2 widely used neural networks, including hierarchical attention network and dynamic memory network as our structure models. And this slide shows the results of our models. As you can see, the structure models have the better performance. It shows that the structured architectures can learn better interrelations between the context information and entity details, which is the important part for reasoning whether a question is ambitious or not. And here is the details of our clarification question generation task. It is a special generation task. It takes ambitious context and entity information as input and generate a clarification question. We adopt a widely used sequence-to-sequence and transformer as our baselines. In addition, we also develop a new generation model based on the features of a clarification question. And generally speaking, a clarification question contains 2 parts, that is entity phrases and pattern phrases. The entity phrases are summarized from the given entity information for distinguish between 2 entities. The pattern phrases are used to locate the position of ambiguity, which is closely related with the context. In summary, 2 kinds of phrases rely on different source information. Based on this feature, we propose a cost-to-fun model. The proposed model contains 2 parts, that is a template generating module and an entity generating module. First, the template generating module first generates a template, and then the entity generating module is responsible for generating a complete entity phrase by combining to the generated entity phrase and the generated template phrase together. We can get a complete clarification question. And here is Here is the comparison between the proposed model and the baseline models. As you can see, the baseline model sequence to sequence achieves lower blue scores, and our proposed cost to fun model achieves the better performance, and the performance improvements show the effective of the proposed cost to fun model. And here is the details of our clarification-based question answering task. We mainly focus on simple question answering, since each question answer pair is related to a single knowledge retrieval. So this task can be divided into two tasks. That is entity classification task and the predicate classification task. They both take context, entity information, as input and output a binary label. And we also adopt structure models and unstructured models and as our baselines. And this slide shows the results of these baselines. As you can see, simple model performs the best. It means that with the help of user feedback, this model becomes very simple. So simple models can achieve the better performance. And here is a summation of the challenges of our data set. The first one is the challenge of evaluation metrics. We found that blue is not very suitable for our data set because there can be various clarification questions, and we only give one possible clarification question. So how to evaluate the quality of the clarification question needs to be further explored. And another question is the problem of long-tailed entity distribution. As we all know, the knowledge base contains diverse entities, and how to learn a robust rule to handle all entities also needs to explored. And to summarize, in this work we construct a clarification question dataset for KPQA. The dataset supports three tasks: clarification identification, clarification question generation, and clarification-based question answering. We implement widely used neural networks as our baselines and for three tasks, and propose a new cost-to-fun generation model. The detailed analysis also show that our data sets bring new challenges, and more powerful models and reasonable evaluation metrics need first explored. Okay, that's all. Thanks for listening.
Thanks. So it's very good timing. Just one quick question. Any questions? No? If no, we will move up. Okay, sorry.
Thank you for your great talk. I'm wondering, you mentioned that the ambiguity is extracted by template. If I'm not make a mistake, I'm wondering if it is sufficient to cover the ambiguous problem in the real situation.
Yes, the ambiguity. In real world communication, ambiguity is very common and it has various types. In this work, we only explore the widely used ambiguity types. So in the future work, we would like to explore more complicated ambiguity types. So thanks for your question.
Thank you.
Let's thank the speaker again.